Hi, welcome to week 3. We're going to be talking about business intelligence tools during this week. Please make sure that you read through everything on Canvas, as there are several selected videos for Tableau Business Intelligence that you can click directly onto via Canvas links and watch those how-to videos on how to navigate within that software. There are also instructions in Canvas on how to download the 14-day free trial and/or the full Tableau version for students. If you have any questions about how to do that, please let me know. This week fulfills the following course objectives. You will be able to identify ways in which data quality can be compromised and learn how to apply remedies. You will be able to communicate analysis results back to management for ongoing quality assurance and process improvement. And you will be able to apply business intelligence techniques to solve specific business problems within the context of the rapidly changing healthcare environment. This week, our learning objectives are the following. 1. Identify business intelligence tools for healthcare analytics. 2. Summarize analytical techniques used to evaluate healthcare data.
It's 3 o'clock.
And 3. Demonstrate use of exploratory data analysis and visualization. So let's start by identifying business intelligence tools for healthcare analytics. You want to be aware that there are open source versus subscription or license-based tools. And whether or not your organization will go more for the open source or the subscription license really depends on the industry that you work in and the organization that you work for. If you are in a health system, you will more than likely be able to utilize a paid subscription or license for a tool, and open source software will be discouraged because of possible cybersecurity risks. Tableau, Qlik, Alteryx, and Microsoft Power BI are the top subscription tools for business analysis using a BI tool. You also want to look at whether or not you would utilize this tool on a desktop, meaning on your own physical computer, or in a virtual environment. If you are using a business intelligence tool in a virtual environment, it makes it a little more challenging in connecting to data sources and working with large data files. However, if your organization has a business intelligence tool in a virtual environment, it is typically much more secure than using it from your desktop. You really want to be aware of the data that you're connecting to, and do not store any data on your local desktop that is not allowed to be there, such as protected health information or potentially identifiable information or personal identifiable information. You also want to think about the business processes, the business rules, and how this data was originally collected. Think about the different ways that these business processes could go wrong, and how would that impact the data. Next, we're going to look at summarizing analytical techniques used to evaluate healthcare data, both for data quality and for ethics. In the chart below, you see on the left side demand and control. This chart explains the process when you may have a data ethics concern. As you start looking at your data, you may see some ambiguity in the data, meaning that the numbers or the data don't match another set of data, or something doesn't look right, and that could cause a conflict. Then you need to define what are the values involved with this data. So for example, we're not talking about a typo in the spelling of somebody's name in this case. We're talking about data that could have possibly been purposely manipulated for some reason. And then we analyze the data to look at possible solutions and effects. If available, we seek out expert opinion, and then we make a decision on what to do with this data for the benefit of the stakeholders for that data. So when you look at data, you want to look at both quality issues, meaning there could be missing data values, there could be data that looks wrong. Think about ages, if you're looking at patient data, whether it's identified or de-identified, and you're looking at ages and you start seeing ages where a patient would be 150 years old, a flag should go off in your mind thinking there's something not right there. If you're looking at dates and it looks like there's a calendar month of 13 or 25, you would want to look at that data further. Maybe it's not in the format that you're expecting it to be. So next we'll demonstrate use of exploratory data analysis and visualization. Before you use any data in any formal method, it should always be sampled for data ethics and quality. We call this process data profiling. So let's start from the beginning. You have a topic or a question in mind. There's some type of health-related question or issue or problem that you're looking to find an answer for. What do you do? Where do you start? So you start looking for data sets. These could be internal data sets within your organization. They could be data sets from other organizations. They could be registries, electronic medical record data, data from the CDC, publicly available data from data.gov, or really any source in almost any format. It could be an Excel file, a text file, on a database, even on a website, or in some other type of structured file. So you go out, you look for the data sets, you read the metadata, which is the data about the data. For example, what are the date ranges? What are the date parameters of this data? Where did it come from? What's the lineage of that data? You explore the data dictionary so that you get familiar with all of the different variables in that data set and what those data variables mean. You download the data if it's a small enough size, or if the data is on a server, you get the server connection information. You connect to the data from within Tableau or other BI tool. You look for the bad data. You make notes if any of the data needs to be prepped and or scrubbed. At this point, you do not want to make any changes to the raw data. But there may come a time where if there are a lot of issues with the data, that you talk with management and other stakeholders and determine if you need to transform that data or eliminate any outliers. Then when you have Tableau open, you drag the dimensions of data into the worksheet under the row and or column section. You drag the measures into the areas in the center of the sheet where you see ABC. These measures could be counts, like the number of records. It could be values, such as length of stay or charges. And then you explore the different table formats by dragging and dropping different fields under rows and columns, and you click on the Show Me tab and explore various visualizations such as heat maps, bar charts, pie charts, etc. Please see Canvas for the selected training videos that will walk you through how to start working in Tableau. The link below takes you to the main training Getting Started page, but in Canvas I have 3 screenshots of selected videos that I think would be best for you to start, as there are many and there are several hours worth of videos. This is the information for the assignment, which is due September 24th. For homework 3, you will also find this in Canvas under the assignments section. I've also included some examples on the next slide. This is some information on getting data from data.gov and looking at overdose death counts. You could look at the accuracy of predicted versus actual deaths. You could also explain any data problems that you found. A second example would be looking at the leading causes of death and determining the top causes of death nationally and per state. This is a screenshot of data from one of the data sets brought into the Data Source tab in Tableau. This is an example of a table of counts in Tableau from the leading causes of death file, and you can see the state and the cause of death name is in the row section, and the sum of the number of records for the deaths under measures, the deaths are showing up to the right in the right column. And this visualization I don't expect you to do, but here's an example so that you can see what can be done geospatially, where you can take that data set and create a heat map on an actual map to show areas where there are more suicides in certain states over other states. Thank you.